You need to implement a AS9100. We'll guide you step by step. Has top management asked you to implement an AS9100 quality management system? Is a customer or the aerospace market you want to enter requiring it? Or do your operations need stronger control, fewer failures, and more reliable results? Whatever brings you here, you are in the right place. MADSOF will guide you through a real implementation, step by step, from the first controlled document to certification readiness, so your organization can reach its goal. First, you need the whole route. Episode 1 shows all 36 steps across 6 connected phases. For every step, you will see what it does, why it matters, and the output that closes it. From episode 2 forward, we return to this map and build every control in practical detail. Save this roadmap, it is the navigation chart for the complete series. Every step has an owner, acceptance criteria, a controlled output, and operating evidence. Approved documents describe how work should be controlled. Records show what actually happened. If the evidence is weak, the step stays open. The route moves through 6 connected phases. Keep the roadmap on screen as we travel. Completed steps lock into place, the current step stays visible, and future work remains clearly ahead. This is a practical implementation sequence, not a clause checklist. Activities will overlap and improve through use. Adapt the route to your products, processes, customers, risks, resources, and regulatory environment. Standards evolve. At our July 23, 2026 source cutoff, the IAQG register still lists a AS9100 Revision D for the Americas, EN9100 2018 for Europe, and corresponding Asia-Pacific editions. ISO 9001 2026 and the next 9100 revision are progressing. Verify the edition, contracts, legal and regulatory requirements that apply where you operate. First, build the backbone, controlled information, process ownership, policy, organizational context, and a coherent map of the quality management system. Step 1. Document control procedure. Control how QMS information is created, reviewed, approved, changed, distributed, retained, and retired. People must be able to identify the current approved instruction and avoid unintended use of obsolete information. Close this step with controlled procedure and master document register. Step 2. Process map. Map the QMS processes and show their sequence, interactions, inputs, outputs, owners, controls, and measures. The map exposes handoffs and dependencies so the system is managed as a network instead of separate departments. Close this step with approved process architecture and interaction map. Step 3. Organizational chart. Define the organizational structure, process ownership, decision authority, responsibility, and escalation paths. Clear accountability prevents important QMS duties from becoming assumed, duplicated, or abandoned. Close this step with organization chart and responsibility map. Step 4. Quality policy. Translate leadership's quality commitments and direction into an approved policy that fits the organization. The policy provides a common decision frame and a basis for meaningful, measurable quality objectives. Close this step with approved and communicated quality policy. Step 5. Interested parties and context of the organization. Identify relevant internal and external issues plus the needs of customers, regulators, employees, suppliers, and other interested parties. Context determines the QMS scope, priorities, risks, and the requirements the system must reliably address. Close this step with context and interested party registers. Step 6. Quality manual. Describe the QMS scope, process architecture, interfaces, and controlled framework at the level the organization needs. A coherent manual gives users and auditors a reliable map of the real system without becoming a copy of the standard. Close this step with controlled quality manual. Now install the controls that lead, communicate, build competence, manage risk, measure performance, and correct failure. Step 7. Strategic management general procedure. Define how policy and context become objectives, plans, resources, responsibilities, review points, and performance measures. Strategy must connect leadership intent to controlled execution and visible follow-through. Close this step with strategic planning method and quality objectives. Step 8. Internal and external communication. Specify what is communicated when, by whom, to whom, through which channel, and what evidence is retained. Planned communication reduces missed requirements, inconsistent instructions, and uncontrolled customer or supplier messages. Close this step with communication matrix and operating records. Step 9. Management review procedure. Define how often management review occurs, who participates, what information is considered, and how decisions and actions are recorded. Leadership needs a repeatable forum for judging QMS suitability, adequacy, effectiveness, resources, and improvement needs. Close this step with management review procedure and agenda. Step 10. Nonconformity and corrective actions. Control identification, containment, disposition, correction, cause analysis when appropriate, corrective action, and effectiveness verification. A disciplined response prevents known problems from reaching the customer, recurring, or being closed without evidence. Close this step with NCR and CAR procedure forms and log. Step 11. Internal audit procedure. Define an impartial, risk-aware audit program with competent auditors, planned criteria and scope, reporting, and follow-up. Internal audits provide an independent view of whether planned controls are implemented and effective. Close this step with audit procedure, program, and records. Step 12. Training. Determine competence needs, evaluate gaps, provide training or other development, confirm effectiveness, and retain records. Attendance alone does not prove competence. People must be able to perform assigned work as required. Close this step with competence matrix and training records. Step 13. Risk assessment. Establish a consistent method to identify, analyze, treat, assign, monitor, and review relevant risks and opportunities. Risk thinking helps the organization prioritize prevention and make proportionate control decisions. Close this step with risk method and risk register. Step 14. Monitoring and measuring equipment control. Identify monitoring and measuring equipment, its status, intervals, traceability, protection, and response to out-of-tolerance conditions. Product decisions are only dependable when the measurement system is suitable and its validity is known. Close this step with equipment control method and register. Next, design the 5 core value flows: sales, engineering, manufacturing, purchasing, and quality control. Step 15. Sales process. Design the flow from inquiry through quotation, contract review, feasibility, requirement changes, and internal handoff. Sales must capture and confirm the complete customer commitment before the commitment is accepted and passed to engineering, purchasing, or production. Close this step with sales process map and measures. Step 16. Engineering process. Design how engineering controls inputs, outputs, reviews, verification, validation when applicable, configuration, and changes. Engineering controls convert requirements into complete, approved product and process information. Close this step with engineering process map and measures. Step 17. Manufacturing process. Design manufacturing planning, controlled execution, identification, traceability, in-process verification, and production release interfaces. A defined manufacturing process makes repeatability and product conformity intentional rather than dependent on memory. Close this step with manufacturing process map and measures. Step 18. Purchasing process. Design supplier selection, approval, requirement flowdown, purchase controls, performance monitoring, and change response. Externally provided products and services remain part of the organization's responsibility to its customer. Close this step with purchasing process map and measures. Step 19. Quality control process. Design inspection, test, acceptance, non-conforming output control, status identification, product release, and record retention. Quality control must provide objective evidence that acceptance decisions use defined criteria and authorized personnel. Close this step with Quality Control Process Map and Measures. Now convert those process designs into daily procedures, work instructions, inspection, material control, and delivery controls. Step 20. Sales Operating Procedure. Convert the sales process design into the roles, steps, forms, system transactions, reviews, and records used every day. A practical operating procedure ensures customer requirements survive quotation, acceptance, change, and handoff. Close this step with Controlled Sales Procedure and Records. Step 21. Engineering Operating Procedure. Convert the engineering design into a controlled operating sequence with required reviews, approvals, records, and change controls. The procedure makes technical work repeatable and preserves evidence that design decisions were properly evaluated. Close this step with Controlled Engineering Procedure and Records. Step 22. Manufacturing Operating Procedure. Define the operating sequence for work orders, planning, materials, travelers, equipment, inspections, status, and release. Manufacturing needs one controlled method that connects planning to completed product and retained production evidence. Close this step with Controlled Manufacturing Procedure and Records. Step 23. Purchasing Operating Procedure. Define requisition, supplier authorization, purchase order review, requirement flowdown, changes, and receiving coordination. The procedure keeps purchasing decisions controlled and ensures suppliers receive the requirements they must meet. Close this step with Controlled Purchasing Procedure and Records. Step 24. Quality Control Operating Procedure. Define how inspections are planned, acceptance criteria are used, results are recorded, status is identified, and issues are escalated. Consistent quality control execution protects the validity and traceability of every acceptance and release decision. Close this step with Controlled Quality Control Procedure and Records. Step 25. Assembly or Manufacturing Work Instructions. Create task-level instructions for assembly or manufacturing, including sequence, tools, parameters, acceptance points, and sign-off. Work instructions translate procedures into unambiguous actions at the place where the work is performed. Close this step with Approved Work Instructions and Evidence. Step 26. Packaging and Delivery. Control preservation, packaging, labeling, required documentation, final release, shipment, and delivery records. Conforming product can still fail the customer if it is damaged, misidentified, incomplete, or released without authorization. Close this step with Packaging, Release, and Delivery Controls. Step 27. Manufacturing Work Instructions, Special Operations. Define special operation instructions, qualified personnel or equipment, controlled parameters, approvals, and retained process evidence. Processes whose results cannot be fully verified later demand disciplined qualification and execution controls. Close this step with Special Operation Instructions and Qualification Evidence. Step 28. Stockroom Management. Control identification, segregation, preservation, shelf life, environmental needs, issuing, inventory accuracy, and restricted material. Stockroom controls protect material identity, condition, traceability, and availability from receipt through use. Close this step with Stockroom Controls and Inventory Records. Step 29. Receiving Inspection. Verify purchase requirements, identity, quantity, condition, certificates, and risk-based acceptance before material enters usable stock. Receiving inspection is a key barrier against supplier errors and undocumented material entering production. Close this step with Receiving Inspection Controls and Records. Step 30. First Article Inspection or FAI. Plan and record a first article evaluation showing that the realized production process can produce the specified product. FAI provides a structured baseline and should align with a AS9100 when that standard is contractually or otherwise applicable. Close this step with FAI method and a AS9100 aligned records when applicable. Step 31. Return Material Authorization. This step is optional when customer returns do not apply. If the organization accepts customer returns, it must authorize receipt, preserve identification and configuration, evaluate the issue, control disposition, and trend the results. A defined return material path protects traceability and converts customer returns into useful feedback. Close this step with return authorization, evaluation, and trend records. Then test the operating quality management system through internal audits, leadership review, and verified improvement. Step 32. Execute internal audits. Perform the audit program against defined criteria, gather objective evidence, report conclusions, and track findings to closure. Execution reveals the difference between the system described on paper and the system people actually use. Close this step with completed audits, findings, and actions. Step 33. Execute management review. Conduct the plan leadership review using performance inputs, risks, audit results, customer information, resources, and action status. Recorded decisions and assigned actions demonstrate that top management actively directs the QMS. Close this step with review minutes, decisions, and assigned actions. Step 34. Continual improvement actions. Use corrective action results, trends, objectives, audits, and feedback to select, prioritize, and assign improvement work. Improvement is credible only when actions are completed and the resulting benefit or risk reduction is verified. Close this step with verified corrective actions and improvement portfolio. Finally, prove that the quality management system can operate over time and support an evidence-based readiness decision. Step 35. Maintenance and operation of the QMS. Operate every process over time. Keep information current, maintain competence, monitor measures, manage suppliers and risks, and retain the required records. Sustained performance proves the QMS is an operating system rather than a short-term documentation project. Close this step with sustained operating evidence and KPI trends. Step 36. Certification readiness or project closeout. Perform an independent readiness review, close open issues, confirm the evidence set, and transfer responsibility from the implementation project to the permanent process owners. Readiness is an evidence-based decision. It does not guarantee certification or replace the certification body's judgment. Close this step with readiness assessment and sustainment plan. You now have more than a list. You have an implementation project organized around 6 milestone gates. Milestone 1 releases the QMS foundation. Milestone 2 puts governance and support into operation. Milestone 3 defines and assigns the core value flows. Milestone 4 deploys operational controls. Milestone 5 validates the system and closes improvement actions. Milestone 6 proves sustained evidence and certification readiness. Use these gates as project release points and tailor the schedule to your organization. Every future episode repeats one practical loop. Define the acceptance gate, build the controlled output, test it in operation, correct the gaps, and close with evidence. Next, we build document control, the safeguard that keeps current instructions in use and obsolete information out. We will define the document lifecycle, build the procedure and master register, and test the workflow with objective evidence. Use this roadmap as a disciplined implementation guide. It does not replace license standards, customer contracts, legal advice, or certification body direction. Verify current requirements, tailor every control to your organization, and preserve objective evidence. Subscribe and continue with episode 2, where we start building.